All right, good afternoon, everybody. Thanks for coming to this seminar. My name is Paul Fricke. I'm a professor at the University of Wisconsin-Madison. I'm also on the board of directors for World Dairy Expo and on the educational committee. And it's my pleasure to introduce Dr. Matt Lucy. He's a professor at the University of Missouri. Should I go through your pedigree, Matt? BS from Cornell, MS from K-State, Ph.D., University of Florida. How many years have you been at Missouri now? 30. Yeah, Matt has had an illustrious career, lots of publications. He's an excellent scientist. He also does some extension type talks like this. And so looking forward to his talk entitled New Perspectives on Aging and Lifespan in Dairy Cows. Matt, the floor is yours.
All right, thank you very much. Thank you very much, Paul. Yeah, so appreciate everybody for being here. It's wonderful to be in the great state of Wisconsin. And I'll tell you what, this is a great topic, and these are very interesting times, you know. Hey, we're in Wisconsin. Okay, it's really interesting in Wisconsin right now. And you know, hey, you got a new quarterback, right, Jordan Love? You know, but it's really, is it really fair to bring up football when I'm from Kansas or from Missouri, right? I mean, it's been a while for you Packer fans, huh? But oh, geez, was that last year? Oh, sorry. And anyways, not going to talk about H5N1. But I will say that I'm a former editor-in-chief of JDS Communications, and we are releasing a short series of articles on H5N1, and that's free and open access, and it'll be released on October 11th at jdscommunications.org. But what I'm going to talk about is lifespan in dairy cows, and I'm going to remind everybody of this cow. I think this cow still holds the record, 13-year-old Holstein cow, producing nearly 500,000 pounds of milk during her 10 lactations. So she certainly lived a long time. And you know, it's been this longevity thing has got a lot of airtime, particularly recently. And there's a couple sides to the equation. Everybody has an opinion. This is an article in Progressive Dairy written by Gavin Staley in June, talking about how important these golden girls are to the dairy. And another article by Richard Pursley, same sort of thing, the importance of holding on cows in the dairy. And then you have the other side of the equation, Steve Eichert writing and showing up in Dairy Herd Management. I think that was probably October 2024, that's a typo, but who's basically asking the question, why are we holding on to so many older cows in the dairy? And stating that, you know, I think dairy farmers are keeping their older cows too long. And so I'm going to talk a little bit about that and talk a little bit about where we got today. So the really question about longevity is, and this probably dates me, and the younger people in the audience have no clue what I'm talking about here, but are you going to have a Yugo or a Mercedes in your herd? And of course, some of the older people might remember that there was a time in the automobile manufacturing where a car named a Yugo was made, and it was designed to be inexpensive and did not necessarily need to last very long. And then, of course, the Mercedes is well known for its durability and lifespan. And so which one is better for the dairy? And we do live in interesting times, and I think that the technology and the economics of milk production have really changed rapidly, and that's why this topic is so important and so timely. You know, everything is changing, and I just wanted to, or everything is impacting this topic, and I just want to talk about climate, technology, and consumers. I think we all know that in 2022 there was a historic drought in the United States, as shown here, particularly in the West, where there were were major areas of beef cow calf production. And of course, now that drought is subsided, but nonetheless, droughts have very long lag times in terms of their impact on the food supply. And so where we are today is that the United States cattle inventory is the smallest it's been in 73 years. And that small inventory is really driving beef prices, essentially, and beef on dairy prices. And so that's the first thing. The second thing is technology. And of course, the important thing to remember, I'll show this paper by Dr. Fricke, who introduced me, and his colleagues, Dr. Wiltbank and Dr. Pursley, is that we are in an unprecedented time in the dairy industry where we have so many tools available to us to get cows pregnant. And so we don't necessarily talk too much about issues with pregnancy, mainly because we have so many options. And then the other technology that, of course, came on board, which was sex semen. And the rapid adoption of sex semen has changed everything as well. And so now sex semen plus this combination of outstanding ways to get cows pregnant led to the beef on dairy phenomenon. And the beef on dairy phenomenon, a combination of sex semen to the production of herd replacements and then beef on dairy, have really left farmers wondering, how many replacements do I really need, because beef on dairy calves are so valuable. And then there's consumers. And the consumers is really, no matter what you read or hear or whatever, I'm here to say that milk does not cause cancer, okay? And I always like to say, 220 million years of mammalian evolution didn't lead to a cancer-causing food, okay? Sorry. But anyways, but the important thing about consumers is they just really, who doesn't enjoy red meat and ice cream, right? And red meat consumption in America remains strong. And dairy consumption, although we consume different types of dairy products, annually the milk consumption, dairy product consumption in America continues to grow. And I think it's all sort of crystallized in this T-shirt my wife bought me, and it says, the T-shirt says, "I didn't claw my way to the top of the food chain to eat vegetables," okay? And that's how I feel about things. So it is, according to this Hoard's Dairyman, which was published a few months ago, profitability is on the horizon, but there are elements of the profitability equation that impact this longevity question, which we're talking about today. And the first one is that dairy replacement heifers the inventory is historically low, and the replacement heifer prices are historically high. And I just want to remind everybody, the last time we had historically high replacement heifer prices was before people like Dr. Fricke and Milo and Dr. Pursley. But it was in the year 2000 when we didn't have all these programs in place. We didn't have all these programs for managing reproduction, and it meant that the reason that replacement heifers were high was because we didn't have enough to keep our herds going. Now we've got the same situation, but it's for an entirely different reason. The reproductive programs are so effective, we don't have enough because people are redirecting a lot of these things into beef on dairy. So next year's replacement heifer inventory is already known, and it's not supposed to improve. So remember, we breed cows and there's a lag time, and it's not supposed to improve next year. Current beef on dairy prices, okay, they've dropped off a little bit, but I talked to my former grad student, Joe Meyer, in Badger Holstein's Unity, and he confirmed that this past summer, they were getting $800 to $1,000 for beef on dairy calves. And they're dropped off a little bit, but nonetheless, this is just a crazy number. And so the only way, if you've got a lot of cows going into if you're going a lot of heifers going, a lot of animals are going beef on dairy, that really puts a little pressure on keeping older cows in the herd to keep your herd populated. And it appears, based on this Hoard's Dairyman article, that that's what's happening. Actually, there, in all likelihood, there's so many calves going into beef on dairy that 2023 will be the first time in over 50 years that milk production has declined in back-to-back years in the United States. So the first time in 50 years we've had a decline in total milk production. And if you look at these data also from hordes on the same day, this is the slaughter cow numbers, okay, for 21, 22, and 23 up here. And this is for 2024. And you can see for the first, through August of 2024, reduced slaughter cow numbers, mainly suggesting that people are holding on to their older cows in an effort to maintain their herd sizes. And it certainly gets, so the importance of an older cow now is certainly also reflected in replacement cow prices, which are now at all-time high, according to this article, now averaging almost $2,400 for replacement cow prices because the cow prices are high, because if we don't have enough replacement heifers, you're going to have to buy a replacement cow. And I was actually, when you looked at these numbers, it is quite stunning, the price of current price of replacements. And so we had a Discover conference in October 2023 in which we talked about this whole idea of cow longevity. And the takeaways were interesting. And we did have Gavin Staley and also Chris Eichert at the conference discussing the two different views, which are wildly different. But I think one of the takeaways that I had from the conference is, we want the best cows on the team regardless of how old they are. And I guess the way to talk about this might be, if you got 1,000 stalls on the dairy, you need the best cows in those stalls, because basically you need milk production per stall to make money, and you've got to have the best cows on the dairy. And the older cows, if you think of them as a senior class, they might not be the best cows on the team. And that's Chris Eichert's point, that the senior class might not be the best cows on the team. You know, if I have a basketball program or a football program, let's go basketball. If the juniors are better than the seniors, I'm playing the juniors. And I might actually bench the seniors, or I might even cut the seniors. I'm playing the juniors. I'll play the sophomores. I'll play the freshmen. Who's ever the best cows to go into those stalls. And that's Eichert's point. And if we understand, but if we're in the current markets where really replacement heifers are so tight and people are forced to keep more older cows, we need to do a better job of understanding the biology of the senior class. And perhaps they can stay on the team longer. And I only say that if that works for your farm, because I don't own any cows, okay? So I got no skin in the game. But if that works for your farm, we need to understand a little bit more about the biology of the older cows. So what am I talking about today? Well, there's three different terms: herd lifespan, cow lifespan, and cow health span. And herd lifespan is really a decision based on replacement rates, and that's a decision that you make as a manager. How long is this cow going to stay in my herd? Cow lifespan is how long can a cow live? You know, people say 20 years. There's not a lot of hard data on there. We don't hang on to cows forever, but people say a cow can live 20 years old. And then finally, there's cow health span. And I think that's what I'm talking about today, is kind of cow health span. Because usually cows leave herds because they're sick or not making milk. So I'm talking about cow health span. How long can a cow stay healthy, and why does she wear out? And we don't know a lot about this topic. It's a very new topic, but it's probably a topic we're going to be talking a lot more going forward. So, but the good thing about aging and cow lifespan, but aging in particular, is there's a lot of scientific interest in aging, because as we all know, the demographics of the population globally is trending towards older individuals, and is particularly trending towards older individuals in America. And so there is a lot written about this, how we age, and a lot of science that goes into how we age. And to a certain extent, the premise of this talk is to at least introduce some of the science that's on the horizon that may move out of the human clinic into the bovine clinic to help cows age better. Now I want to give an acknowledgement to my good friend, Dr. Scott Polk, who's such a good friend. He's right at the and Scott and I work on everything, and I just want to remind everybody that we want the best people on the team regardless of how old they are, okay? So, so this is just important. And Scott gave me these data, and Scott maintains a very large database, and these are 40 herds, 1,000 cow herds over the past several years, and he just summarized some of the reasons cows are culled. And these reasons for culling are consistent in the literature. Basically, cows leave herds because they get mastitis, get lame, have some sort of a disease event, reproductive failure, poor production, or they simply die. And that Scott's summary is pretty consistent with what a lot of the summaries will say. And recently published in the Journal of Dairy Science was a couple of papers out of some fairly prominent authors, Ian Lean in Australia, but Steve LeBlanc, Todd Duffield from Guelph, and Jose Santos from University of Florida, which tried to summarize exactly why are cows leaving the herd, and what is the impact of age on when they leave the herds. And in this study, in these 4 graphs, they're looking at mastitis, ketosis, lameness, and metritis. And the way you read these graphs is the first parity. So a first calf heifer is set to 1, and everything is expressed relative to the first calf heifer. And these are the different parities, 2, 3, 4, and greater than 5 across the bottom. And basically, you can see as a cow ages, the incidence of mastitis increases, ketosis increases, lameness increases. And the way you read this is that's a 5. So that number is a 5, which means that if a cow has over 5 lactations, she's 5 times as likely to be lame on your herd, okay, in these data sets. And the only disease that a first parity heifer is more likely to contract is metritis. And we just submitted a paper to JDS Communications on this, and we think that's because the first calf heifer has never been exposed to the bacteria that cause metritis before. That's her first exposure to those bacteria, and we think that after that first exposure, when they go into 2nd, 3rd, or 4th, or 5th lactations, they've already seen those bacteria, so they're less likely to contract metritis. That's what we think that's about. But other than metritis, basically, you see the data on aging. And fertility is the other thing that declines with age. And so they have a series of, this graph is depicting the decline in fertility as a cow ages. And to read this graph, what you have to look at is they wanted to correct for the amount of milk production that individual cow was making. So they graphed it based on that cow's deviation from herd milk production, either from minus 40 kilograms per day to greater than 40 kilograms per day. First of all, you notice that the shape of the curve is kind of a rainbow shape. And that's because low-producing cows don't get pregnant and high-producing cows don't get pregnant either. And the reason that the low-producing cows don't get pregnant is because if a cow's not making a lot of milk, she's usually sick or something's wrong with her, so she's hard to get pregnant. And we all know about some of the relationships between pregnancy and high production. But the other thing you see is it doesn't, regardless of their level of milk production, as a cow ages, they're more difficult to get pregnant. So I want to just take a few moments to just talk a little bit about the why, all the different whys about this. You know, why does this occur? And I want to talk a little bit, so we're talking about lameness, mastitis, and infertility, and I want to talk a little bit about the why. The interesting thing about the why is when I read this paper from these experts, I was a bit stunned at their conclusions about the why, which was basically, we don't know why, okay? We don't know very well why these things happen in an older cow. So their conclusion was there needs to be a better understanding of the pathophysiology of older dairy cows and changes in metabolism with age that underpin the increased health risk and increased parity. Okay, but there's no real good why out there, why cows age. So there's only about 2 or 3 cows where we're going to talk a little endocrinology, a little bit about hormones, but we have to get through this because this is central to the why question. We have to get through this. This is central to the why question. And so cows do something sort of very interesting. The words we use, and again, they uncouple their somatotropic axis. And I'm going to explain what I mean by uncoupling their somatotropic axis and producing more growth hormone and less IGF-1 when they lactate. I'm going to talk about this. This is their normal biology. Okay, so the normal biology of a cow is when she has a calf, she has an increase in growth hormone in her circulation. And that increase in growth hormone is important for driving milk production. Now, some of you in the room are old enough to know when we used to treat cows with bovine somatotropin to increase milk production. And what was, and I'm an old Monsanto guy, so what we were doing with that treatment was increasing growth hormone in her circulation. We were recreating the natural situation that occurs when a cow calves to drive more milk out of cows. Now, the key driver in this whole process, which is interesting, is a decrease in a second hormone in the bloodstream called insulin-like growth factor 1, and you'll come to understand that very critically in a second. But this IGF-1, okay, goes down, okay? When it goes down, growth hormone goes up because these two guys talk to each other. I'll cut to the chase and say IGF-1 is a hormone that's found in young, healthy individuals. IGF-1 is a hormone found in young, healthy individuals. And here we have a cow with low IGF-1 concentrations associated with milk production. So that's what I'm going to say first. So the way this all works, cows make milk. And when they calve, they start making milk. And when they start making milk, they redirect glucose in the circulation for the production of lactose in milk. So they immediately go down in glucose concentrations. And when they drop in glucose, their insulin concentrations also decrease. And when their insulin concentrations decrease, this affects this endocrine axis. So there's no real easy way around the fact that when a cow starts making milk, she's going to suck all the glucose out of her body to make lactose. And when she does that, her insulin concentrations are going to go down. It's the same insulin that we have, that we think about insulin and glucose. Same thing, same biology, same everything. And the issue with that is that the insulin controls this IGF-1 axis. And when the insulin goes down, this receptor goes down in the liver, and IGF-1 concentrations go down in the bloodstream. So one of the reasons we talk in transition cows, everybody's talking about transition cows, liver cow health, transition cows, liver cow health, is because the liver of the cow is coordinating and organizing this axis. And if the liver's messed up, it messes this up too. When the IGF-1 concentrations go down, there's like this negative feedback communication thing that controls growth hormone. So when IGF-1 concentrations go down, growth hormone concentrations go up in the circulation. What growth hormone does in the circulation is it drives gluconeogenesis. It increases the capacity of the cow to make glucose. So when we treated cows with BST, why was it so effective? The reason it was so effective is when you treat a cow with BST, you increase her ability to make glucose. You also increase her ability, you also sort of inhibit the amount of fatty acids going. You increase her capacity to make glucose, and you secondly liberate fatty acids that can be used for milk fat. That's why that works. And it's the same biology here. So, but the problem is when we see this decrease in IGF-1 right there, that, which is so critical to that, that's basically contrary to everything but the production of milk. So the scenario I just described, a lot of growth hormone, low IGF-1, low insulin, it's what I just described. That is what you want to make milk, without question. We knew that when I was an undergraduate, which was 40 years ago at Cornell. We talked about that. That's how you make milk with cows. The problem is all the other parts of the cow in terms of her muscle, her immune system, and her reproduction, that's not what they want. That's not what they need. So if you think about what happened, the reality of the situation is this. And this is not a knock on geneticists, it's just a reality of the situation. Globally, not just in America, throughout the world, the only thing we selected cows for until 1994 was the production of milk. The single thing that we selected for was the production of milk. That's not a US thing, that's a globally. And if you select only for milk and ignore everything else, that's what you get. In other words, you get this biology, because this biology is the fastest path to an increase in milk production. So we'll get to it at the end, but you know, now we select, if you look at net merit, milk production is only 40% of net merit. Now we select for lots of things, okay? But at the time, when most of these cows were set up, this was what you got. And it's nobody tried to do this, nobody meant to do this, nobody knew about this, it's just where it ended, okay? And now I can cut to the last slide, but now we're in the process of trying to correct some of this stuff. So I said that IGF-1, it's a growth factor, it makes things happy, and of course, in repro, there's tons of data like this, but we know that, you know, cows calve, the IGF-1 goes down, it does increase in time, but cows that ovulate early, that start to cycle, have greater IGF-1 than cows that don't cycle. So the ovary depends on IGF-1 to start cycling. And the thing about it is, and that relates to this IGF-1 situation, is that all cows have a decrease in IGF-1, and I said that this is at calving, they have a decrease in IGF-1, and I said this is really important for muscle, immune function, and reproduction. As you age, your IGF-1 levels go down further. The older you are, the less IGF-1 you have in circulation. That's called, they call that somatopause, but that's what they call it. It's this process of aging and reduced concentrations of IGF-1. So not only do you have this genetic situation going on, you have the additional situation where as a cow ages, it's not getting any better. And that relates to our longevity question today. You might be surprised, it's a little bit strange, but the best way, if you're a person, the best way to increase your lifespan is to eat less and actually drive down your concentrations of IGF-1 by eating less. That's another way you can drive down concentrations of IGF-1. Eat less. But you know, we're not going to feed lactating cows less. That's not a good plan, so that's not an option. So these are data from monkeys. These are great studies in monkeys where they do caloric restriction in monkeys. Okay, feed monkeys less for 20 years. This is what monkeys look like after you feed monkeys less for 20 years. This is the control. That's the monkey you fed less for 20 years. And you can see right away that, yeah, you can extend lifespan with this kind of a treatment. That's not a treatment option for us at all. For you those who want to jump in on this, there's a big trial going on in people if you want to jump in on this one, okay? I tried to get Scott in on this, but it didn't happen, all right? But there's a big trial on this going on in people. So the point of the story is that if we want to keep cows longer in our herds, then we need to understand why and how cows age. And we need to treat aging like a disease and not a foregone conclusion. And that's kind of where we are even medically. Medically, the question is this. You know, you're just supposed to get old and deal with it, you know? And maybe we need to, the medical community is really struggling with that question. Okay, should we just let people get old, or should we try to help them not get so old so fast? It's an interesting question. So, and the top journals, so Cell, it is the #1 journal, scientific journal. They write about aging all the time. And in this journal, they talk about, there's 12 different elements to aging. And I'm only going to talk about a few of those, and I'm going to talk about stem cells, old cells, and inflammation. I'm going to talk about stem cells, old cells, and inflammation as it relates to dairy. So before I talk about stem cells and old cells and inflammation, I just want to deal with one question. And a lot of times people say, well, cows, dairy cows, they make a lot of milk, they have a super high metabolic rate, they age quickly because they have a super high metabolic rate. You know, they're really aging because of the metabolic rate. And the answer to the question is maybe, but there's not a lot of strong evidence to support the idea that a highly metabolic animal is going to age more quickly. And that theory of aging is called the free radical hypothesis. This is the idea that when you're highly metabolic, your tissues produce substances called free radicals, and those free radicals damage cells. And that, at best, might count for a 5 to 10% loss in lifespan. It doesn't get you to the situation where cows are supposed to live 20 years and basically culled from most herds before they're 5-year-old cows. It doesn't get you there. That's not going to get you there. So I want to talk about 3 different things. I'll talk about lameness, I'll talk about mastitis, and I'll talk about inflammation. And of course, everybody basically, when we talk about lameness, they usually blame the concrete flooring. You know, that's the first thing they'll say. It's because of the floors. And okay, maybe, but maybe there's more to that. You know, if you think about the time budget for a typical dairy cow, this is a time budget I got at Michigan State University. You know, eat for 3 to 5 hours, lay around for 12 to 14, you know, stand around for a couple, drink for 30 minutes. If you went to your doctor and said, you know, doc, I don't feel so well, and you showed him and you said, well, what do you do all day, Dr. Polk? What do you do all day? Well, I eat for 3 to 5 hours, I lay around for 14, and then I kind of like stand around a little bit. He'd be like, well, I can tell you why you're not, you know, you're not getting enough exercise, Polk. You need to exercise more, all right? He does need to exercise more, but don't, you know. You can, this is how I treat my friends. Can you imagine how I treat my enemies? But the point of the matter is there has been a lot of work on exercising cows, particularly you can exercise them during the dry. If you exercise them during the, when they're lactating, it's not a good plan. You just lose milk when they're exercising. And you can exercise them during the dry period. And the conclusion of exercise during the dry period is that you can really, during these studies, they really did pick up that the older cows are in a poorer physical state of fitness. They're in just poorer fitness compared to the younger cows. And the reason that animals lose muscle mass, and the reason why people lose muscle mass is that animals lose muscle mass as they age, people lose muscle mass as they age. You know, why does your grandmother fall over and break her hip? Because there comes a time in her life when she has so little muscle mass that she can no longer stand upright and balance, and she falls over and breaks her hips. That's what it is. It's a loss of muscle mass. Muscle is maintained by stem cells. And as we age, we have fewer and fewer stem cells. As you have fewer and fewer stem cells in muscle, you lose muscle mass. And so, as you lose muscle mass, that's the issue. So part of the question is, you know, as cows age, what do we know about their loss in muscle mass in aging? And how many of our issues surrounding sort of mobility in an older cow is simply because they're losing muscle mass? And so IGF-1 is essential for maintaining muscle mass. IGF-1 is known as a myokine, and IGF-1 in people and mice and other stimulates those stem cells to maintain muscle mass. So one open question is whether or not, as cows age, they simply do not have adequate IGF-1 to maintain stem cells, to maintain their muscle mass as they age. How can we improve muscle mass? Well, not a ton of options other than exercise. Exercise is critical but that's not really an option in cows necessarily. But there is this concept of whether or not we can formulate amino acids in diets. We normally formulate amino acids for milk and protein synthesis, but it's pretty well accepted that amino acids have nutrient values beyond that. And the amino acids that seem to be fairly important are branched-chain amino acids like leucine, which are known to basically stimulate muscle protein synthesis in people. So one of the questions is there a way to feed a cow a certain blend of amino acids that might help her maintain muscle mass? And this is the only, I just want to say this, and this is an intercellular pathway, and I think it just needs to be said. We understand a lot about how to maintain muscle mass. Low insulin, low glucose, and lack of exercise, those three come together to basically inhibit muscle protein synthesis. Muscle protein synthesis is coordinated by a molecule. It's called mTOR. We know a lot about mTOR, but these things come together to basically inhibit muscle protein synthesis. Branched-chain amino acids like leucine have the capacity to work in an opposite direction. So branched-chain amino acids have the capacity to stimulate mTOR, to stimulate muscle synthesis. So it's possible that there might be value in certain amino acids that go beyond their value for the production of meat and milk. That's the point. The other thing that happens when we lose muscle mass, when we lose muscle cells, they die. And when a cell begins to die, that's called a senescent cell. And those cells that begin to die release something called a senescent cell secretory program. And those dying cells cause inflammation. And I think if you've attended one of Barry Bradford's seminars, you know all about inflammation in dairy cows, and we don't want dairy cows to have inflammation. Just like we don't want inflammation in our own joints. The biology is not that all different. So as you lose muscle, you get inflammation. Now, senolytics is this idea that's very hot right now in humans, that can we use drugs to basically remove dying cells in muscle and reduce inflammation by reducing dying cells in muscle. Now, fair enough, that might be a little bit, if it's not even approved for humans, it'll probably never get approved for cows. But nonetheless, again, in the journal Cell, this was recently published, this concept of nutri-gerioscience approach. So nutritional geriatric science approach to reduce the amount of dying cells in tissues. And so their point is that it's probably going to be possible if we study these things and do a little more work on these things to maybe design diets that have the capacity to reverse some of these effects of aging in dairy. Now, of course, if you're a small producer and only feed one ration, it gets kind of hard because your first calf heifers are eating what your older cows and everything else. But if you're a larger dairy and have the capacity to feed different pens, it seems like the future, in all likelihood, is going to be feeding your older cows different than your younger cows to try to capitalize on some of this new research. Why mastitis? Well, that's a good question. Why does an older cow get more mastitis than a younger cow? And again, this goes back to the fact, and there's a lot of reasons for this. You know, older cows produce more milk. There's more metabolic imbalance. We know that, for example, older cows get more ketosis. Ketosis makes cells of the immune system unhappy, basically. It makes them unhappy. Aging, but the other part of this is just the effect of aging on our immune system. And the fact that, again, going back to this IGF-1 story, IGF-1 has a capacity to reverse some of these effects of aging on the immune system. As we age, our immune system changes. Why do we get sick when we get old? Pretty decent question. The reason you get sick when you get old is because of something called myeloid balance. And just basically what it means is that your cells of the acquired immune system, your cells that make antibodies in response to disease, you're losing those cells. You're losing the bone cells, the hematopoietic cells in your bone marrow that generate those T and B cells that make antibodies to combat disease are going away as you age. By the time you hit 65 as a human, it's like, boom, okay? 65 is a bad year. I'm 64. I got another year. And they're replaced by cells of the innate immunity. Innate immunity is important, but these acquired immune cells, you're losing those. Now, interestingly, the data would suggest that this molecule, IGF-1, which again is low in lactation and low, is important for maintaining those stem cells in your bones. And so basically, as this is data from mouse, again from Cell Stem Cell, one of the top journals, as mice age, they lose stem cells. But if you get them on IGF-1, they repopulate those stem cells, okay? And that's the important message. Now, I'll finish off with inflammation, because inflammation is a big deal in dairy. There's a tremendous amount of inflammation when a cow calves. That's normal. There's a tremendous amount of inflammation when the cows get metritis. That's normal. There's a tremendous amount of inflammation when cows get mastitis. That's normal. But inflammation should never, what's weird about inflammation, we see this with cows with metritis, right? Cow gets metritis, 10 days postpartum, she's harder to breed at 100 days postpartum. She's more difficult to get pregnant. I mean, why? She had metritis when she was 10 days postpartum. Why am I struggling to get this cow pregnant? It's messed up. The reason you're struggling to get that cow pregnant is because the cells of the cow remember when there's an inflammatory event. Why are transition periods so critical to get right? Because all that inflammation occurs at within 30 days of calving, and it goes away, but the cells remember that. I remember I was in Clovis with Dr. Polk. We teach a class together. Can you believe that? And then I tell the lies, he tells the truth. But nonetheless, and I talked to this guy in Clovis, New Mexico. I said, well, tell us about your repro program. What's the key to your repro program? He said, well, I just get my transition cow pen right and everything's fine. That's what he said. And that's because of memory, cellular memory. And so cells have a capacity to remember that. But the problem is, once they have that memory, how do you get rid of that? And that's basically this whole concept. Another concept that's out there in the aging science is, how do I erase the memory that cells have? How do I take that cow that had metritis and erase the memory of metritis from her, or mastitis and erase that memory, or liver disease and erase that memory? And that's called reprogramming. That's a process where you basically reprogram the cow's cells or reprogram the individual cells to forget that inflammatory thing. Make her feel like a young cow again. And if we look at this cellular reprogramming, it seems like that's not possible. How could I make an old cow feel young again, be young again? Well, reprogramming in a mouse leads to a younger mouse. Those two mice are the same age. But one has her stem cell factors reprogrammed. So it's possible. Will it ever happen in dairy? I don't know. But it's possible. It'll probably happen to us. And maybe not Scott and I, but maybe Scott's children. I don't know. We'll see. So what are we doing about it? I'll conclude with this. Where do we stand with this? Well, if we think about longevity or productive life in the net merit index, productive life, we now, as I mentioned, sorry to bounce around here, but now, as I mentioned, about 40% of net merit, if you're using net merit, about 40% of net merit is milk traits. So we've gone from 100% to 40%. And of course, net merit now has lots of fertility traits, but it also has longevity and productive life, which is kind of what we're talking about today. It's about weighted about 15%. I want to tell you about an experiment that's going on in Ireland. And in this experiment in Ireland, the Irish use a slightly different genetic selection index, but it's also weighted heavily for fertility, longevity, and has about the same weighting in milk. And so in this experiment, and this is called the next gen herd in Ireland. Okay, so this is called the next gen herd, next generation herd study in Ireland. And basically, if we look at the Irish equivalent to if we look at the Irish equivalent to net merit, it's called the EBI, or Economic Breeding Index. And you can see even in Ireland, before they introduced the EBI in 2000, they were 100% milk. Everybody was 100% milk. Don't let anybody tell you different. But over time, they have reweighted everything, and they've got a really kind of a heavy weighting on fertility and heavy weighting on longevity. Now, what's interesting about this experiment is they did genomic testing. They purchased the most elite cows in the country of Ireland, genomic tests, and put them into this herd and milked them side by side with average Irish cows, genomic average Irish cows. Same herd, same grass, same place. And they studied these cows. So this is basically the effects of genetic selection when you weight longevity and fertility equal to milk. And so the first thing you find out is if you make them equal, elite and average, they make the same amount of milk. So let's just make the point. These cows make just as much milk. The elite ones and the average ones producing the same amount of milk. Now the elite ones, this is body condition postpartum for elite versus genetic average. So the elite ones basically hold on to more body condition. There's other ways to make milk. You don't have to have a cow that loses a lot of weight to make milk. That's what that basically said. Yeah, and I know these are not North American Holsteins. I get it, okay? But there's other ways to make milk other than losing a lot of condition. The second thing you notice is when they do this, and you look at IGF-1 and insulin, the topic of today, low IGF-1 and low insulin, okay? Yeah, their cows go down in IGF-1, their cows go down in insulin. Not a big difference, but you see how the insulin concentrations are moving up in the elite animals? See how the IGF-1 concentrations are moving up in the elite animals? In other words, when you balance the selection, you start to normalize some of these hormones that we've been talking about today. And furthermore, when you plot their overall survival, and again, that's the topic of today, how long will a cow stay in my herd? you can see that this is a survival curve through 4 lactations, looks like. Let's see, I don't know, anyways, however many lactations, you can see that the survival of those elite cows is much better than the survival of national average. In other words, when you balance the genomic selection, you get a cow that's going to live longer. So maybe not today, but maybe in the future. I mean, I think if nothing else, if none of these other options, the nutrition option or anything come through, performing a more balanced genetic selection, achieving the same amount of production, will likely, if the selection is balanced and the genes are there, you'll likely end up with a lot longer lived cows based on this study. So with that, I'd like to thank everybody very much. I do have a podcast called Dairy Digressions, and if anything said here that was of interest, listen to Dairy Digressions. Look for Fricky's episode because it's a great episode. Thank you very much. Thank you very much, everybody.
Matt, thank you very much for that presentation. The floor is open for questions right now. If any of you guys have any questions. All right, we have one right here. Go ahead.
If you go back to one of your slides where you had mastitis, fertility, and lameness for older cows, and metritis was about the same. I know there's a biological effect, but is it because we don't know how to manage those older cows?
Yeah, right. So that's a good question. So do we just simply not know how to manage them? You know, certainly, I think there's potential a lot of questions about housing. You know, how maybe they need a little bit different type of housing. They certainly maybe need a little bit different type of flooring, you know, potentially. And you know, in the United States, the herds have gotten so large that creates opportunities, because now maybe we can put the older cows in a certain barn that might work better from them. You know, this whole longevity thing, it just has been so understudied and so sort of underappreciated, because you know the Eichert argument is pretty logical in my mind. I just need to put the best cow in the barn, in the stall. What's really made his argument a lot more logical is there was a time, and I don't know Scott's, and I tease Scott all the time, but there was a time when a cull cow wasn't worth anything. Now they're worth a lot. You know, so I can put them on the truck and do okay with them. And so Eichert's argument carries a little more weight because of the value of a cow, cow you sell is so much more now, you know. And so I don't know, but there is not a lot of information on how do we keep cows around longer. In Europe, there's a lot of public pressure to keep cows longer. You know, the public knows about the fact that we cull cows at 5 years old. The public knows that cows are supposed to live to 20, and they expect action on that. You know, and then the Europeans, we were just at this Discover conference, and sometimes people play little games with different, you know, dairy. Well, our cows live longer, and I don't know. You know, they do live longer in Ireland, but a lot of the confinement dairies, regardless of where they are, they live about the same amount of time.
Okay, Randy.
So, very interesting slide at the end there, or near the end. This one's interesting.
This was interesting, right? Okay,
Yes.
but this one.
Yeah, your point that we don't need to lose body condition, you know, to get milk.
Yeah.
And it almost feels like if we switch our genetic, and this might end up being a question for Paula, not for you.
Yeah.
But if we switch our genetic focus, we can get there, and then we don't have to lose body condition to get milk.
Mm-hmm.
Well, if we're breeding for milk, why didn't we get there?
If we're breeding for milk.
Well, if we were breeding for milk, why didn't we get those cows? You know, why the divergence, I guess? Why did we end up with having to lose body condition to get milk genetically instead of these elite cows?
Yeah, so that's an excellent question. So I can give you my interpretation of my answer. So again, up until 1994, we selected on milk. And up until 1994, that was before the genomics era. And before the genomics era, it took six years to prove a sire. And the very first record you got on that sire's daughters was 60-day milk production. So the very first record you got on sires was 60-day milk production. And the other thing which is true is that the peak milk production is highly correlated with total milk production per lactation. So I think to a certain extent, the cows that made more milk lost a lot of weight early and redirected energy into the production of milk, and were always favored in that scenario. And of course, always favored in that scenario. And when I was at Cornell, that's what we were taught. I mean, that was the lesson, that these cows lose a lot of milk, and this is how they get up on milk and they go out. And so body condition was important. Loss was important. That was an important element of it. And then so the other element of that is just the way we look at sort of lactation curves. You know, every part of the lactation curve is heritable. Every part of persistency is heritable. You can select cows to hold on to milk, but you got to wait a whole lactation to figure out who's a persistent cow and who's not a persistent cow, because you don't get that record until she's been throughout the whole lactation. So persistency is another element of this. It's never been selected for, because it's true that peak milk is highly correlated with total milk, so people don't think too much about persistency. Back in the BST era, everybody loved the BST cows because they would hold on to milk. They would flatten out that lactation curve, particularly if she wasn't pregnant. They would really flatten out. Now, I didn't put it in here, and I still want to. One of the things that I started thinking about was first lactation heifers. We know first lactation heifers are more persistent. And they're also younger. But they're more persistent. How does a cow become more persistent? She basically holds on to the cells that are making milk. That's why they're more persistent. And so I thought to myself, you know, instead of viewing that as a suboptimal animal in my herd, we should view those cows, those first calf heifers, as really an opportunity to basically understand why do they hold on to milk, and how can we get an older cow to hold on to milk like that. You know, Joe Myers sent me from Badger Holsteins. He sold me a record for a cow. The cow was 890 days in milk and making 86 pounds of milk. I mean, what's the deal with that? Give me a full herd full of those cows, okay? But so I think that's how we got there. I think it was just, you know, when we did genetic selection, those cows were the ones you wanted. Those were the daughters that, those bulls got the best proofs. I think so.
All right. Any other questions? I think we have time for one more. Yeah, Matt, I was thinking about this data. Matt and I were at in Southern Ireland on sabbatical at the same time. You think, so those Irish Friesian cows, I think you mentioned this, what, they give a third of the amount of milk as our North American Holsteins? And they have an experiment going on there in Ireland where they have North American genetics cows with orange ear tags and the Irish ones with green. We didn't have to have the ear tags in the ears to know which one was a North American cow versus which one was which.
Yeah.
I'm just, do you think we have the same kind of phenotypes in our, I mean, our North American Holsteins that give so much milk, are they just genetically programmed to strip off that body weight?
Yeah.
And you know, we've associated that with poor fertility, obviously.
Yeah.
But I don't know. Is there data similar to this in the North American Holstein, you think?
Yeah, so that's a good question. So the question is, have we completely bred this biology out of North American Holsteins? You know, is it gone? Is this genetics gone? Yeah, and so there's one thing about a Holstein. You could select the Holstein to take a left turn at a stop sign if you wanted to. Okay, I got news for you. If you can measure the phenotype, you can get there. If you can measure the phenotype, you can get there. So my guess is that the genetics is not gone, but if you can measure the phenotype, you can get there. Now, actually, the reason body condition score, if you just were to phenotype body condition score, which we do not do, is actually a pretty good proxy for overall reproduction in cows. In other words, when I was on sabbatical in New Zealand, they explained to me, we can either put in, first service conception rate or body condition into our selection index because they tell us exactly the same thing. So my guess is that over time, if you keep the pressure on the repro, you're going to find out that you'll get the milk and they'll have better body condition score as well. I don't think there's anything broken about our cows, and it's just a matter of how we weight these things. But the thing that makes it super tricky is the decision of what weight you place on those traits. There's, I don't know, I think CDCP does the net merit index. And as you know, everybody's economics of a herd is different. Every herd has unique economics. And net merit is simply their best guess at what we should weight. Net merit is supposed to be, I think, a profitability type index. And net merit is just their best guess at what we think we should weight these things to make a profitable cow. And what you should weight them in your herd might be slightly different. And that's why some people pick bulls that have certain traits that they think are valuable to them and other people don't, And so it's just their best guess of what's out there. So I think, I just don't believe that the genetics are no longer out there. I think they're out there. It's just a matter of kind of bringing them to the top. That's what I think.
All right, one more question.
Okay, and there's another question.
One other question.
Back there.
My gut instinct says that it's a combination of all the things you're saying there. The problem is all of us look at some kind of economic indicator to tell us how to judge these cows and when we should give up on them or put more faith in them, all the way from to how much do we stress them by overcrowding, what's the right percentage there,
Mm.
or how many times we put semen in there.
Mm.
I'm sitting here wondering now, so okay, if I base the whole herd on net merit index, should I, I'm trying to grow that, should I turn around and override that in the breeding program now with longevity and productive life, weighting it more heavily that way?
Yeah.
But it sounds like what you're telling me is it's basically a matter of time. If you still put your faith in net merit, we're all going to get there eventually anyway. Cows are going to be productive longer.
Right. That's what these data would say, because they basically, with identifying and selecting those elite cows, they basically looked at cows 20 years in the future. That was the concept of this project, was to look at cows 20 years better than the current, the average, genetic average. And so I'm not smart enough about economics and to know how to play with net merit. I am smart enough to know that everyone's economics for their herds is different, Yeah.
Another comment here?
I just had a question, like when you're talking about reversing and forgetting the memory of the information and so on, like with the mice and whatever, like how long does it take to forget that?
Yeah, so basically that reprogramming is, well, obviously, it's fast.
Okay.
It's fast.
Okay.
Yeah, it's fast. So you basically, okay, this is mouse work, okay, but pretty crazy, right? So it's fast, and so and there's been a lot of work on this concept, and so where we're at now is you need a method to deliver the I don't know, chemicals that do it, and so that's kind of where things are now. But in all likelihood, it's kind of the future for people as well, you know.
Are you taking those chemicals, Matt?
No, I don't. But it's kind of this kind of reversing thing, and then there's just a tremendous amount of work on reversing memory, reversing like scar tissue formation, fibrosis. You know, that's always an interesting question. I know we got to go, but I was always interesting. Like, if a cow loses a quarter, how come you can't get it back? And I think it's because it's full of scar tissue and stuff. And of course, that's a big area of study right now, is how do you get rid of scar tissue? Because after we have a heart attack, why does our heart not work well? Because that heart attack introduces scar tissue into the scar tissue replaces our heart muscle cells. And so there's a lot of work being done now on how do I sort of remove that scar tissue with a, you know, not with a surgical knife, but a cellular thing, and then promote the stem cells that will replace that damaged tissue. And I always thought about that, you know, like, she's a 3/4 cow. How come she's a 3/4 cow forever? Why doesn't anybody work on that, you know? It's interesting. I don't know. It's interesting.
Heifers are cheap. We just
Heifers are inexpensive.
we just get rid of them. They were.
The flooring.
Well, if we come back to, okay, let's get the cells reprogrammed and so on, I hope their management changes as well to support that health to keep ongoing.
Fair enough.
Yeah.
Excellent point.
All right. I'm going to go ahead and wrap this up. Let's give Dr. Lucy another round of applause. Any of you who are interested, if you want ARPAS, I think this is good for 1 credit in ARPAS. Anybody interested? Maybe Dr. Polk is interested in that. You can get one credit for ARPAS, so I guess talk to the people outside. Thank you again for coming. Please fill out the survey. We're always interested in what you guys think. So thanks.